Hey everybody, welcome to the first Physics 211 video review. These are short videos I'll be putting together every semi-regularly, and the goal of these is to sort of review things that I've noticed a lot of students have trouble with in office hours. Seeing as I'm more or less the office hours guy for this semester of Physics 211, I figured I'd be pretty well equipped to go over some things that I think would be very helpful to know in general. So this one is going to cover some quick review on kinematics, trig, and some general strategies for physics. And we're also going to talk a little bit about some specific algebra called substitution. So we're going to start off with the most important part, which is looking at some general strategies. Now, a lot of high school physics education is going to encourage you to just know or guess at an answer, and that doesn't really work out for a problem solving strategy. You want to look at problems systematically. So our first step is we want to write down everything we know about the problem. That's any equations, that's any numerical values you're given, any conditions you need to know, what you're trying to solve for, everything like that. And doing that helps you organize your thoughts and reminds you of important information you might forget. So you can avoid a lot of mistakes that way. Then, if it's applicable, you want to diagram the problem. Usually we also want to add force vectors. You may have heard these called free body diagrams. That's just a term for it. But basically, you want to get a visual sense of what the problem looks like. This helps with your physical sense of what's happening here, and it will help you catch mistakes. Then finally, once you have all these equations and all this information written out, you want to look at what you have and try to find a path to the answer. So you'll be using algebra, you'll be using trig, maybe identities, substitution, anything like that that will move from what you have to what you want to get to. So stepping back from these general strategies for a bit, we're going to talk about trig and kinematics. Both of these are algebraic equations. So if you have the same number of equations as unknowns, you can solve. So if, for instance, so that means if we know all but one variable, you can solve the equation. So for trig, if you know any two parts of the equation, you can solve for all of it. You've got these formulas down here and you've got them labeled on the triangle as well. And you can see that if, for instance, we know the angle and the hypotenuse, we can solve for adjacent, we can solve for opposite, we can solve for tangent, etc. And then there's also some useful identities that I think are just always good to know. And these are the only things and these are good to memorize because they come up a lot. So looking at kinematics, kinematics are similar. If you know all of but one variable, you can solve the equation. So if you know three kinematic variables, that's a, x, initial velocity, final velocity, and time. If you know three of those, you can solve for all of them. So I've written all the kinematic equations down here. They're very easy to just look up if you have access to online resources. And if you have an equation sheet, they should definitely be on there. Anything like that. So note also that sometimes you're not going to be given three variables straight up. Sometimes you need to use logic to find another one. So if we're talking like projectile motion, we know that at the top of the arc, Vy is equal to 0, right? So this is also the thing I really want to talk about today, which is substitution and solving algebraic equations. So you've got a couple tools to solve systems of equations. And what you want to get at fundamentally is you want to put unknowns in terms of our knowns. There's a lot of tools to do that, but today we're going to focus on substitution. So we have our typical Atwood's machine. We've got two asymmetrical masses subject to gravity, and the rope is frictionless, so we don't need to worry about anything with that, and they have a tension. So we want to solve for A in terms of just m big M, and G. So try writing out the steps and words, pause the video, and you should be able to do it. See if you can do this pretty quickly. Moving on. So we write out Newton's second law for both masses. We solve for the tension. We get rid of the tension T by substituting because we don't want that in our final answer, right? We only want M, big M, and G. And then from there, we can solve algebraically for A. The steps are completed under that black box there. I realized this problem was on your homework, so I decided to not give the answer. But this should give you a sense of how to start these problems all the time. So now, see if you can tell which of these steps are which. My work is a little frazzled here, but see if you can identify how I'm setting up these equations and which step corresponds to which math. So you can see I start with Newton's second law, right with these equations with the tension. I solve one of the equations for tension, and then I substitute for tension in the other equation. And from here, I have all the variables I want, so I can solve algebraically for A. So the thing I want to end with today is that being good at physics is all about discipline and dedication. There's not like some deep physical talent that physicists have. They just use their brain power better. So don't be afraid to just try stuff. You can always ask corrections and you can always ask questions and make corrections later, especially with the homework. Feel free to just try all the problems and then ask questions and fix what you got wrong later, because trying the problem and doing it wrong is going to help you learn much more than just not trying at all. And then if you're still struggling, make sure don't be afraid to ask for the TAs, the coaches, Walter. They'd all be happy to help you. Finally, as I mentioned, I'm tailoring these around what I see in office hours. If you have any feedback on the lecture itself, the content, audio, video, presentation style, send me an email at jtpaustian@sear.edu, and I'll make sure to incorporate that in the next one. Thank you, everybody.